Today's shoes, pandas, dunks, design, a name, and a date. Yeah, we're gonna try to speed run this. Already had the stencil on, did a little bit of mining before the cameras turned on. Hopefully it turns out good. We're doing it, it's a simple design, we're just doing white. But requires much focus. Recently kind of watched the new Fantastic Four movie. And there was a scene where they're near a black hole. And that scene brought back some cool information I knew back when I did a uni course on astronomy. And they were near a black hole in this scene. And it was cool because it made me remember all that stuff about time dilation that I learned about. I was sitting there thinking, like, trying to see how accurate everything was to what I knew, like the science behind everything. And honestly, it wasn't that bad. You spend that much time near a black hole, time goes by insanely fast in comparison to the world that they were going back to. They were going back to Earth, but that had to be at least months. They were moving. Yeah, no, it had to have been at least months because they were by that black hole for like 5 minutes. Real time, our time. All time is real time, but like, you know. And the reason that's pretty unrealistic is because of time dilation. Basically what that is time moves slower the stronger gravity is pulling on you. The stronger the gravity that you're experiencing, the slower your time is moving. That's why some planets, like if you watch Interstellar, like they go to like other planets. Interstellar is very accurate. They go to other planets and stuff that have stronger gravitational fields, and like a second there is like 10 minutes on Earth. It's that type of stuff. So yeah, when your gravity is strong, your time moves slower, and it also correlates to speed. So when you're going, like, again in Interstellar, they're going at the speed of, almost the speed of light. It's impossible to go to speed of light, but that's different. It's a whole different thing. But yeah, the faster you move, the slower the photon clock is. And that is like the actual test they did. There's a ball that goes up and down. Once it bounces to the top, imagine this flip. How it is with speed is that it has to travel more distance to reach the top because it's not just a straight path up. You gotta imagine it like a diagram like this because there's motion. The more distance you're covering, the more distance this photon has to cover to reach the top, and likewise to reach the bottom. Let me lock in real quick. But yeah, back to the movie. They were at a black hole, and the gravity of the black hole is insanely strong. It doesn't, common misconception, I mean, that black holes like suck everything around it in. That's not true. It's just the closer you get to a black hole, the stronger the gravitational pull is, to a point where you gotta like be traveling insane speeds to get out. That's why light can't even escape it, because it traps light. The pull is so strong that it traps light, which is pretty crazy. So they were moving closer and closer. And I want to talk, but yeah, the black hole, I'm just gonna say, the black hole has something called the event horizon, which the name is crazy in itself. There's a point, if you take your body and you go towards a black hole, you reach, or like a ship or whatever, you reach in the event horizon, which means there's no other event that can happen after it. That basically means that you can't escape for yourself, go into something else real soon, but you can't escape it because you're at the event horizon. There's no other event that can happen. You can't go deeper into it. You yourself went towards it, and someone was watching you from a safe spaceship, just watching you. For them, you move towards it more and more, but you're moving slow in their view. Your life is going continuously. It's not like you're in this dimension where you can't where your brain is not processing anything. You are processing something. You're gonna die though. Like, you're cooked. You're not getting out of that. But the person watching you is seeing you. Once you reach the event horizon, they cannot see you. You reached a point where nothing new can happen. You're still in place. You're gonna get brighter and brighter, but you're not gonna disappear for them, which is crazy. That's crazy because the light isn't traveling. You're reaching a point where there's no more, you can't process anything else for them. But what's happening to you is you're moving closer to it, and you actually get pulled in. And there's a thing called spaghettification where your body stretches out. It pulls you from your feet and it pulls you in. Your body gets stretched. It's kind of cool because we don't know. We just know what would happen if someone gets closer. You don't know what would happen. We have a theory what would happen when the person gets into a black hole. You know what, this makes sense, we'll go with it. Okay, it's not Zeus or like Thor striking a hammer and throwing lightning bolts. I think Aristotle, who believed in Zeus at the time. But yeah, so oh my god, these shoes. I'm wondering if this is too small, honestly. Should have gone like right here. But yeah, they were at this black hole and they were like, they mentioned it. They mentioned how there's time dilation and how they did the calculation and stuff. They went to a whole different planet, traveling through like a wormhole, which you have to reach like, I think they did reach the speed of light to get into it. That's already like come on, they're so like, come on now. And then they went to a black hole and then they came back to Earth and no time passed. But it was cool seeing it. And I know I'm just geeking out about it, but peel it off. Actually, that looks pretty good, honestly. Turned out nice. So that's good. What was I yapping about? You know what's crazy? I don't know, maybe it's not as crazy as I think it is, but in my opinion, it is crazy. We can actually travel into the future. It's just we can't come back. Because that's a whole paradox. But yeah, we can just take my word for it for now. We can't go into the past, we can go into the future. Time dilation is basically going into the future. If you go people are currently, if you do manage to go to the future, like in the extent of like the movies and stuff, you go into the future, you know what is to come of your world, and you could technically can do that right now. You live on top of a mountain and there's people who live on the bottom. You guys have two different gravitational pulls. The people on the bottom are pushed down by gravity. The people at the top are further away. The people on the bottom are aging faster than the people on the top. The Caucasus region, there's people who live on the mountains, do look younger. It takes years to really come into effect, but they do look younger. And that's because there's less gravity pulling them. There's less gravity in play on them. There's still a good amount of gravity and it's minimal, the difference, but there is technically less. So the people on the bottom are aging faster technically, and that's kind of what I mean by being able to travel to the future. The faster you move, the photon clock has to cover more distance before a second passes. The Fantastic Four movie, you go so fast anywhere, just go anywhere super fast. Interstellar is a better example. He's seeing these recordings of his daughter giving him messages and stuff because he's out into outer space. He's moving at such fast speeds, and he's seeing his daughter grow up because she's stagnant, she's stationary, as for him moving crazy speeds. That is technically in the future. He went to her freaking deathbed. He was there. That's so wild. He came back the same age, but the whole world was different. He's in the future for himself. So it is possible. Just possible to travel the speeds. It's possible to time travel. Spread your tiny wings, fly away. Alright. That's what it is. You can't go into the past and kill your grandfather because then you'll die. Because no one ever gave birth to you because you ended the bloodline and whatnot. Where you never existed. You do, if you exist in the past, that means like you don't exist in the future. It's just you don't exist in the past. So you can't be in the past. that's kind of like how I see it. The grandfather paradox is fair enough. It is true. I'm not saying it's wrong, but you don't need to get that extreme is what I'm saying. It makes it seem that you could go to the past if you just don't kill your grandpa. It exists. It doesn't, like, that's what I'm saying, doesn't make sense. Oh yeah, let's see how this turned out. So it's pretty clean. No paint blade, that's what I like to see, baby. We're out of battery, we need to charge the camera. I'll just show you the finished product.